Welcome to Chapter 3, Session 4. In the previous session, we explored natural numbers, integers, and rational numbers. In this session, we will extend our understanding of number system by studying irrational numbers, real numbers, their properties, and motivation for introducing complex numbers. Let us begin with the irrational number. Recall that rational numbers can be expressed as fractions of two integers, and their decimal representation either terminating or repeated in the predictable patterns. However, not all numbers behave this way. Some decimal numbers continue forever without repeating any pattern. These numbers are called irrational numbers. For example of these irrational numbers include square root of 2, square root of 3, square root of 5, pi, and the Euler numbers e. This number cannot be written exactly as fractions. Despite this, they play a very important role in mathematics and real-world applications. For example, a square root such as square root of 2 and square root of 5 are frequently used in geometry when calculating distance and length using the Pythagorean theorem. The number pi is used in calculation involving circles, while Euler numbers is fundamental in exponential growth, finance, and the natural logarithm. Now let us move to the set of real numbers. A real number is any number that can be written in the represented on a number line. The set of real numbers include both rational numbers and irrational numbers. In other words, the real number system combines all numbers we have studied so far into a single comprehensive system. The real number system is important because it allows us to solve many equations that have no solution in the rational number systems. Every point on a number line corresponds to exactly one real number, and every real number corresponds to a point on the number line. Like other number systems, real numbers have several important properties. The set of real numbers is closed under addition, subtractions, and multiplications. It is also closed under division, provided the divisors is not 0. Real number satisfies the commutative, associative, and distributive properties. They also contains identity element. 0 is additive identity because adding 0 does not change a number as we stated before, while 1 is the multiplicative identity because multiplying one by number by 1 leaves numbers unchanged. Every real number also has an additive inverse, and every non-zero real number has a multiplicative inverse. This property makes the real numbers systems highly structured and useful for mathematical analysis. Another important concept is the ordering of real numbers. We can compare any two real numbers using the symbols greater than, less than, or equal to. This allows us to arrange the number on the number line and analyze relationships between them. Real number can also be represented using interval. Interval provide a concise way to describe continuous range of numbers. Depending on whether endpoints are included or excluded, we can have an open intervals, closed intervals, or half open intervals. Next, we introduce the concept of upper bounds, lower bounds, least upper bound, and the greatest lower bounds. This concept helps us describe the limit of sets of real numbers and are essential in advanced mathematics and calculus. One of the most important characteristics of the real number system is completeness properties. This property states that every non-empty set of a real number that is bounded above has a least upper bound, and every non-empty set that is bounded below has a greatest lower bound. These unique properties distinguishes real numbers from the number systems and form a foundation for the calculus. Finally, we briefly introduce the concept complex number systems. Although real numbers are very powerful, some equations still have no real solutions. For example, the equation x squared plus 1 is equal to 0 requires the square root of -1, which is not a real number. To solve such equations, mathematicians develop a large number systems called the complex number. Complex number extend the real number systems and provide solutions to equations that cannot be solved using real number systems. They are widely used in engineering, physics, electronics, computer science, and many other scientific fields. Thank you for your attention, and see you in the next session.